Okay, if I'm going to predict the products of a chemical reaction, the first step is that I have to figure out what? What kind of reaction is it? Right. Once I know what reaction type it is, I know what pattern to use to predict the products. Once I have the products predicted, what are some things I need to look for? Special elements. What else? Multiple charges. Okay. Swapping and dropping of ionic compounds. Okay. Things like that. What is my last step once I've done all of that? Balance the whole reaction. Now, if I can't get the reaction to balance, what have I probably missed? Okay, it's possible, but I mean, like if I've been balancing, I've tried starting it with like basically everything in the reaction, but I still can't get it to balance. Where is my most likely place that I've messed up? Right, I probably have one of my subscript numbers wrong, and that could be one of two places. I either swapped and dropped something wrong, or I missed a special element. Okay, one or the other. It's usually drop and swap. Okay, if you can't get a reaction to balance, double check your drops and swaps. Okay, so I want you to write these ones down, okay, give them a try, and then we'll go through them a bit at a time here. All right, so for our first reaction here, I got a hydrocarbon reacting with oxygen, so that's what kind of reaction? Okay, what are always the products? All right, do I need to apply both balancing rules? Yeah, it's an even number, right? So we'll put a 2 here. That'll give me 4 oxygens. 2 times 8 is 16. So 8 times 2 is 16. Okay, and then I've got 8 oxygens here, plus 8 more is 16. Actually, what can I do with all of those? Reduce them. Yeah, okay. I could divide all of those down. It's only because I made a weird compound. It should be C2H6, but it's a typo. That, otherwise it wouldn't work. But, okay, there you go. All right, so that one we could reduce, okay, just because it's a slightly different layout, okay? And it's something we would notice. I would not do that to you on an assignment or test, just so you know, okay? I would give you ones that follow the pattern. Okay, let's look at number 2 here. So I've got sodium nitride reacting with magnesium. What kind of reaction is that? Single replacement. Okay, so who's magnesium going to swap with? Sodium. Okay, so I'm going to have Mg end up with nitrogen and sodium end up by itself. Single replacement reactions have the most things to check in the products. Okay, I have a single element, but it's not one of the special ones, so it doesn't need any numbers. Okay, I have an ionic compound that needs to be dropped and swapped. -3 plus 2. All right, so the 3 comes here, the 2 goes there, and now I've got my compound built. Now I can balance the whole reaction. Okay, so let's look at probably balancing nitrogen first, okay, because if I put a 3 here to balance the magnesium, I might be changing that in a minute. Okay, so 2 here, now I have 2 nitrogens on this side. That gives me 6 sodiums, so I'm going to go back over here and make 6 sodiums, and in actual fact, I could have put a 3 there, and that'll work. Okay, everybody all right with that? And then our second one here, or sorry, our third one, we got Mg3N2, which was one of our products in the other reaction, but now it's doing what? It's decomposing, right? This is a simple decomposition reaction. So that's going to produce magnesium and what? Okay. Is nitrogen special? What does it come as? Okay. So the nitrogen's already balanced because it's 2 on each side. I just need a 3 here to make everything else work. Okay, keep going on that, guys. Okay, so for number 4 here, I've got sodium permanganate is reacting with iron 2 sulfide. How do I know it's iron 2? All right, it balances out with sulfur's -2. Okay, so what kind of reaction is that? It's a double replacement reaction. Okay, so I'm going to swap the metals. So iron is going to end up with permanganate, and sodium is going to end up with sulfur. Okay, they're both ionic compounds, so they both need to be dropped and swapped. Okay, this is a -2, this is a +1, so we're going to have Na2S. This is a -1, and this is a +2, because we figured that out on the other side. So this will need brackets with a 2 outside of the brackets. All right, which means a 2 here will fix everything. All right, questions on that one? All right, number 5, what kind of reaction is that? The synthesis reaction. Okay, I've got copper as a metal reacting with fluorine as a gas. Okay, so what am I going to get on the other side? Yeah, single compound that contains copper and fluorine. But copper has more than one possible charge, and they didn't tell me which one. Which one is it? Most common, which is 2. Okay, and now it's all balanced. Okay, so there's all these little details, right, that we don't want to forget. Okay, and that's where practice is important, right? Like hopefully you've been practicing at home on those worksheets and checking the key as you go, okay, and making sure you get all those little nitpicky details. Jackson, you have a question? It doesn't. Lead can be 4. There's 2 and 4 for lead, right? As possible charge. So that's how. Yeah. Okay, let's have a look at number 6 here. So we got H2SO4, so hydrogen sulfide, or sulfate, sorry, hydrogen sulfate, reacting with magnesium hydroxide. So both ionic compounds, what do I do with the metals? Okay, what's the metal in this compound? Hydrogen. Okay, so that means that magnesium is going to end up with sulfate, and hydrogen is going to end up with hydroxide. Okay, well, that's water, so it's good. Okay, swapped and dropped already. Okay, this one is a -2, this one is a +2. They're already balanced. Now I got to balance the whole reaction. Seems like a 2 here would probably do it. Okay. All right, give you a few more minutes before I go over 7 to 10. If you're done 7 to 10 and you haven't finished up the reaction worksheets, I'd work on those a little bit. Okay, tomorrow's going to be you're going to have a quiz on it, and then we're going to work on the assignment. Okay, and you want to be pro by then. Okay. Okay, so for number 7, we have tetraphosphorus pentaoxide alone. So what kind of reaction is this? Simple decomposition. So it's going to break down into phosphorus and oxygen, which are both special elements. Oxygen is a 2, phosphorus as a 4. Okay, now, a little bit of an issue here in trying to make this balance. Okay, I've got 5 on this side, 2 oxygens on that side. So I'm just going to put a 2 here so that I get rid of my odd number, even number kind of issue. Okay, so I've got 10 on this side. Now I have 10 on that side. Okay, what do I need to put in front of the P? A 2. Okay, and that's good. All right, for number 8, I've got tin reacting with beryllium nitride. Okay, what kind of reaction is that going to be? Okay, who does tin replace? Beryllium. All right, so beryllium is going to end up alone, and tin is going to end up with nitride. What's the most common charge on tin? 4, right. Okay, so I've got a +4 and a -3. So we drop and swap SN3, N4. All right, then we got to go back and balance. So I would say probably start with the nitrogen. Okay, it's got the biggest number out of all of these. So we'll put a 2 there, which balances my nitrogen, but gives me 6 beryllium. Okay, and then I need a 3 in front of tin, and it's good. Okay. Questions on 8? All right, for question number 9. Okay, I've got 2 ionic compounds, sodium bromide and lead 4 sulfide. Okay, how do I know it's lead 4? Well, sulfur is a -2, and there are 2 of them. So that gives me a total of 4 negative charges. That means that this single lead has to have enough positive charges to balance it off. Okay, so I'm going to have on this side then that lead will be with who? Bromine. Okay, and sodium will end up with sulfide. Right? These are both ionic compounds, so I need to drop and swap them. This is a -2 and this is a +1, so we'll have Na2S, and this is a -1, and this is a +4 as we figured out, so we're going to have PbBr4. Right. Now we got to balance everything, so we can go with our biggest number here, I would say we probably need to put a 4 in front of this to balance the beryllium, and then a 2 in front of this to make 4 sodiums on that side. That happens to make our sulfur work, okay? And there's still 1 lead on both sides. Okay. And then the last one. What kind of reaction has 2 elements to start with? Synthesis. Okay, have I played my little trick again? I don't have a lot of tricks, so I kind of repeat them. Okay, I have calcium and sulfur. That's going to make an ionic compound where calcium, has to be listed first. Okay, sulfur has a -2 charge. Calcium has a +2 charge, so that's already dropped and swapped as CAS. Now we just need to balance. And that would do it. Okay, so expect very similar stuff, not only on your quiz tomorrow, but also on the assignment. Okay, and as I said before, your assignment is going to have 30 reactions on it. All right, the first 10 will be, they'll be written out in formula form, the complete reaction, reactants and products. You will have to identify the type and write it in words and balance. Okay, for the second set of 10, you will get a reaction that is written out in words, and you will have to write it out in formula form, identify the type, and balance. And then the last 10 will just be the reactants in formula form. You just have to predict the products and balance. Jackson? No, I mean, probably a lot of you will be done at the end of class, but no, it's not really fair for me to do that, because then time becomes part of the equation, which it is on your test, but for that assignment, no, it'll be a little bit. Well, I mean, they're all kind of the same type. I'm not going to ask anything like harder than that in terms of prediction. There's only so much I can do with prediction, right? Now, if it's just a balancing thing, I can ask you a tougher one, right? If it's just balancing and naming, then I can ask a tougher one.
So if you have 2 double reactions, would they replace who?
2 double replacement reactions on one.
Like NADR plus PDS.
Oh, well then it wouldn't be a double replacement reaction. It would be something else entirely. Like we're just dealing with the kind of basic, kind of binary type of reaction types. Well, they have to be reduced. I can't write it. I can't write lead 4 sulfide like this. Well, not if that 2 is there. It can't be. If I write it like this, then it's lead 2 sulfide. Right? But if I write it with that 2 there, it's lead 4. Does that make sense? Yeah. But I can't write it like this. I always have to reduce. That's a good question, though. Okay. Any other questions or concerns with reactions? All right. So we're done with labs for this unit. Okay. You're going to have your assignment that's coming in for marks here starting tomorrow. You still have a couple of quizzes, and we got the mole equation yet to go over. Okay. That'll be starting Friday. We'll start the mole equation. That'll involve a little bit of math. So you're going to need to bring a calculator with you starting next week. Okay, so make sure that you've got a calculator. It needs to be able to do like exponents, so it's got to be a scientific calculator. You don't have to go out and buy the $150 TI, whatever number we're on now. Okay, as long as you have a scientific calculator that can do exponents and powers and stuff. 13th. That's a long way off. Yeah, I know. Well, I didn't want to make it due around your test, right? You got enough to study for with your test coming up, so I didn't want it to be due around your test, right? So I made it due after. Okay, you still got some time here, guys, so I still want you working. You got 5 minutes left in class, so working on the reaction worksheets, or maybe you start studying a few things. You got a test coming up, okay? Maybe you do a little planning for your toxin project. Maybe you say, oh, on the weekend I'm going to do this, or something like that. Okay, lots of things you could be working on.